Hello guys! Today, Hello Kitty and friends are going to take us on a tour of their village of philosophy. The first one is Hello Kitty. She will talk about the introduction of John Hospers and his book and the deductive and inductive reasoning. The next stop is Cinema Roll. We will learn about the law of nature and the principle of uniformity of nature. Going to the little twin star's house, we will tackle the fallacy of begging the question and solving the problem of induction. Pom-Pom Puddin will provide us with the principle of induction and the nature of inductive reasoning. Moving on to My Melody's house, we will learn about the reliability of inductive inference and required evidence for different levels of generalization. His neighbor Pochaco will give us traits of generalization, falsification, general rule, and 2 requirements for a good generalization. And for our last stop is Kurumi's house, where we will know the fallacy of hasty generalization and 3 guidelines to test a generalization for reliability. So without further ado, let's go to their village. So John Hospers was an influential American philosopher who significantly impacted political philosophy. So his teaching emphasized clear communications of philosophical concepts, and he sought to clarify questions about ethics, aesthetics, and individual rights. So his book entitled An Introduction to Philosophical Analysis serves as a clear and accessible entry point into philosophical concepts and methods. So the book is problem-oriented, aiming to engage students in active philosophical practice rather than merely presenting ideas. It incorporates practical examples and dialogues to illustrate complex ideas, making it a revered course in the field of philosophy. Now, let's delve into his book and discuss the problem of induction. So during high school, we already tackled the concept of deductive and inductive approaches, especially in research. So deductive starts from general to specific idea, while inductive is the opposite. This concept is quite similar to philosophy. So deductive reasoning refers to arguments that we can logically deduce or arrive at the conclusion from the premises. If the premises are true, then the conclusions must logically be true. So we start with the major premise to a minor premise until we arrive at the conclusion. So the example is, if all cars are vehicles and all vehicles are modes of transportation, then all cars are modes of transportation. So the major premise here is all cars are vehicles, then the minor premise, which is all vehicles are modes of transportation. So the conclusion is, therefore, all cars are modes of transportation. So Hospers applies deductive reasoning extensively in his philosophical works, using it as a tool to clarify complex concepts and address fundamental questions. So by employing this method, he seeks to minimize ambiguity and foster clear understanding in philosophical discussion because deductive reasoning is certain. So next one is inductive reasoning. Inductive reasoning refers to conclusions that do not logically follow from the premises. The premises are the only evidence for the conclusion. It is only probable. So example, every time you turn on the faucet, water flows out. So you have noticed that each time you have used the faucet in the past, you have observed that turning it on results in water flowing out. So you have established a pattern from these repeated experiences, leading you to believe that this will be consistent in the future. Thus, you conclude that it is likely, though not certain, that the next time you turn on the faucet, it will produce water. So the most significant distinction between deductive and deductive reasoning lies in their certainty and probabilistic nature. So deductive reasoning provides conclusive certainty when the premises are true, making it a foundational aspect of logical argumentation. Conversely, inductive reasoning acknowledges uncertainty and adapts as new observations are made, resulting in conclusions that hold varying degrees of likelihood rather than certainty. So this duality in reasoning forms the backbone of philosophical investigation, as both forms cater to different aspects of knowledge and inquiry. Next is a quote from the book that says, "Often, however, the fact that something has occurred repeatedly in the past is not taken as evidence that it will continue to occur in the future." So this perspective suggests that past occurrences may not reliably predict future events, indicating a limitation of inductive reasoning in establishing certainty. So example from the book, in past centuries, people got from one place to another on the backs of animals. If you had lived 100 years ago, would you have said it was probable that this would continue to be a main source of transportation? Perhaps if you saw no alternative horseback riding is easier than walking and will probably continue to be so. But if you had noticed a few new inventions such as the bicycle and the automobile, you would say the new inventions are faster and more efficient. I think it's probable that this will largely replace horses and camels. So it's more likely that people will continue to do what's easiest for them, that they will stick to one practice indefinitely. Next is the law of nature. So the law of nature refers to principles that govern the natural world, often regarded as inherent truths about existence and morality. So some examples are Newton's law of motion, the principle that killing is wrong, and natural rights such as the rights to life and liberty. So according to Hospers, when it's a law of nature, we expect it to continue to operate in the future, unlike historical phenomena like transportation via animals. But why should we expect it to continue in the future? So according to the book, a law of nature is defined so as to be open-ended. If it stopped in the year 2000, it wouldn't be a law of nature. It's certainly true that this is how we think about the law of nature. However, that doesn't guarantee that these patterns will hold in the future. Just defining something doesn't make it real, and saying a law will always work in the future just because we defined it that way isn't enough. We can create definitions for words, but there might not be anything real that matches those definitions. It's possible that the laws of nature, as we understand them, do not exist. David Hume raised this point in a passage in the book. To simplify the passage, he talked about the experience of eating bread. He explained that when he ate a specific type of bread before, it nourished them because of its certain qualities. However, just because that bread nourished him does not mean that all bread, even if it looks and seems similar, will nourish him in the future. He pointed out a conclusion people often draw, that similar things will have the same effects may not necessarily be true. He acknowledges that people often believe that if something has always worked in a certain way in the past, then it will work the same way in the future. But he also asks for an explanation of the reasoning behind this belief. He wants us to understand how we conclude that similar things must have similar results, and he challenges anyone who insists that this reasoning is clear and logical to explain. And thus, Hume lays down the challenge: how do we get out of this impasse? This is where the principle of uniformity of nature comes in. It says that as the laws of nature have been in the past, so they will be in the future. So we're not just talking about specific events like flipping a coin and getting heads every time, but about the laws of nature themselves. So the idea here is that if a scientific law like gravity has held true before, we expect it to hold true in the future too. In simple terms, since law X worked before, it will work again. However, this creates a problem known as begging the question, which means that you are assuming what you are trying to prove. It's a bit like trying to lift yourself off the ground by pulling on your shoelaces. It just doesn't work. Hume suggests that we expect things to happen the same way in the future because of habits and past experiences. For example, if someone has been nice to us before, we expect them to be nice again. If a dog has been treated well, it will trust and wag its tail. If not, it will be cautious. This highlights the mental reliance we have on past experiences while questioning whether that reliance is a solid basis for predicting future events. Here are the 3 solutions to solve the problem of induction. The first is the linguistic solution. In the book, a skeptic questions the idea that past experiences can predict future events, while a common-sense philosopher argues that they can. The skeptic believes that there is no proof that things will continue to happen in the same way in the future based on past events. For instance, just because a pencil has fallen when dropped every time in the past does not mean it will fall the same way next time. The philosopher disagrees, saying that the pencil falling repeatedly is a strong evidence that it will fall again. They ask, if this is not evidence, what do you think would count as evidence? They feel confident that because they have witnessed this pattern many times, it informs their expectations for the future. The skeptic responds that they don't consider past events as evidence for future ones. They want something specific to happen in the future to prove the point, such as actually dropping the pencil and seeing it falling again. They argue that no current event can serve as proof of what will happen later. The philosopher questions the skeptic about what type of evidence or reasoning they would accept. The philosopher feels that if the past falling of the pencil isn't convincing, then nothing will be. The skeptic maintains that they require a future event to consider it proof, and this leads to confusion about the meaning of evidence. The philosopher argues that if you're not willing to see past events as a good reason to expect future events, then it will show a close-minded approach to reasoning. The linguistic solution posits that many philosophical problems arise from misunderstanding and ambiguous uses of language. By paying closer attention to the way we use language, philosophers can potentially dissolve this problem. One is pragmatic justification. The main idea here is about how we can use past experiences to definitively predict the future, nor can we use those experiences to prove that our prediction methods like induction are effective. This creates a challenge because we often rely on patterns from the past to make predictions about what will happen next. Instead of trying to prove that our prediction methods work, we can use pragmatic justification where we justify why we choose to adopt them based on their usefulness. Just like we only support a rule in baseball if it makes the game more interesting. We adopt the principle of the uniformity of nature because it helps us understand how the world works and allows us to make predictions about future events. Although we don't truly know if nature will behave consistently in the future, but using scientific methods like observation and experimentation give us the best chance to discover new things. Relying on random guesses or mystical practices like crystal gazing isn't effective for making reliable predictions. It's like a patient undergoing surgery without knowing if it will save her life. She does it because it's her best option. There's also a concern. What if, in the future, some other non-scientific method becomes more effective at revealing the secrets of nature? Just because scientific methods have worked well in the past doesn't guarantee they always will. If nature changes in unexpected ways, we may have no way of knowing which method will be useful for making accurate predictions. This leaves us in a tricky position about trusting our current methods to always be the best one. The last one is validate methods of induction. There is no such thing as a general justification for induction. Some people think that it's unfair to expect the process of induction to be like deduction. Induction and deduction are different types of reasoning. While you cannot validly deduce future conclusions from past information, that doesn't mean induction is less valid than deduction. It's like expecting a dog to act like a cat. Each has its nature and way of functioning. Instead of trying to justify induction as a whole, it is more practical to validate specific methods of induction, like asking if random sampling produces reliable results. The goal is to find out which specific induction methods are trustworthy rather than proving that induction works in every case. If we were to seriously examine whether induction is justified, we would likely be asking if people have enough evidence for their conclusions. The answer would be mixed. Sometimes people do have adequate evidence, and sometimes they do not. However, this realization does not provide deeper insight into the nature of induction itself. Many people might agree with the idea that things will stay the same, as it seems reasonable. However, the debate sparked by Hume's question is still ongoing. We need to ask whether anyone has truly proven that nature won't change dramatically in the next 10 minutes. If such a radical change were to occur, it would mean our understanding of what counts as evidence might be wrong. Scientists tend to assume that nature will behave as it always has, but this assumption could just be considered a type of faith in science. Despite this uncertainty, scientists continue their work without reflecting on these deeper concerns, while it has continued to fascinate and plague philosophers.
Now, let's move on to the Philosophical Analysis 7th edition, Module 3 and 4. Here is Andresito E. Acuña's Philosophical Analysis 7th edition, and today we will tackle the Unit 4, Analysis of Natural Arguments. Let's start with Module 3 entitled On Induction. First, let us know the principle of induction. In philosophy, the term induction is ambiguous. It has several important uses. The epistemologists use the term induction to refer to a general principle which states that events in nature are regular and not random. This means that the past may not be identical to the future, but it still has similarities. In the language of John Stuart Mill, he said that we must first observe that there is a principle implied in the very statement of what induction is. An assumption with regards to the course of nature and the order of the universe, namely, that they are such things in nature as parallel cases, that what happens once will, under a sufficient degree of similarity of circumstances, happen again, and not only again, but as often as the same circumstances recur. This, I say, is an assumption involved in every case of induction. And if we consult the actual course of nature, we find that the assumption is warranted. This universal fact, which is our warrant of all inferences from experience, is that the course of nature is uniform, that the universe is governed by general laws. This principle of induction is the fountainhead of all empirical arguments. This principle allows you to connect one particular event with another event. You know that all direct experiences are about particulars. Without the principle, event will be isolated, unconnected, and unrelated from one another. It is the same principle that allows you to compose an argument using as premises what you have observed to a conclusion that is unobserved. In simple terms, if something happens once under certain conditions, we expect that it will happen again if those same conditions occur. This is what allows us to make reliable predictions. Along our discussion, we will encounter these words: nature of inductive reasoning, reliability of inductive inference, and required evidence for different levels of generalization. But first, let's tackle about the nature of inductive reasoning. Inductive reasoning, according to Acuna, it involves making conclusions that extend beyond the evidence presented. It connects the observed to the unobserved, moving from the known to the unknown or familiar to the unfamiliar. In short, inductive reasoning let us make educated guesses about the unknown based on what we've already seen and experienced. To fully understand, let me give you another meaning according to Indeed Career Guide. Inductive reasoning is a method of logical thinking that combines observations with experiential information to reach a conclusion. When you use a specific set of data or existing knowledge from the past experiences to make decisions, you are using inductive reasoning. For example, if you review a population information of a city for the past 15 years, you may observe a consistent rate of population increase. If you want to predict what the population might be in the next 5 years, you can use the evidence or information you have to make an estimate. This is inductive reasoning. The next one is reliability of inductive inference. To fully understand reliability of inductive inference, let's use the example from Acuña's book. It is a box containing 100 marbles of unknown color. For example, you draw one marble and it reveals that it is white. This confirms the claim a marble is white, requiring no inductive inference. Or this means that you are not making a prediction or generalization, you are stating facts or direct evidence. However, it provides indirect evidence for the claim a few marbles are white, which does involve inductive reasoning. Since you want to know more about the colors, you draw 9 more marbles, which will lead you to 10 white marbles. You can say that the evidence in the sample of 10 white marbles confers certainty to a many claim and probability to a most claim. When the sample size increases with 30 white marbles, the claim most marbles are white becomes highly probable, and you can assert almost all marbles are white. However, all marbles are white remains only probable. To recap and summarize the required evidence for claim, some means there's at least one white marble. Many means there are at least 10 white marbles. This shows a good number of them are white, but it's not necessarily the majority. Most means more than half of the marbles are white. If there are 100 marbles, at least 51 of them are white. Nearly all or almost all means 80 to 90% of the marbles are white. So if you have 100 marbles, an evidence of 80 to 90 of them are white, while all means every single marble is white. If you have 100 marbles, all 100 of them are all white with no exception. Please take note that the terms few, some, and several are examples of systematically vague language. These words are intentionally imprecise and can vary in meaning depending on the context in which they are used. Their exact quantity or scope is often not fixed, and the domain in which they are applied can change how many or how much they imply. Let us now move on to the next module, which is Module 4, Generalization.
Many of you may be familiar with the term generalization as it is a common type of reasoning that we often use. However, some of you may not be aware of the requirements for making a good generalization. By the end of this module, you will be able to construct effective generalizations, evaluate their strengths, and avoid fallacy of hasty generalization. Using the example of Karl Popper, let us further discuss the challenge of generalizations. Are you familiar with crows? Imagine you observe a number of crows. You notice that all crows you've seen are black. So from this, you conclude that all crows are black. But what's the problem here? The evidence you are basing this on is simply the crows you have encountered. Maybe 5 different occasions with about 50 crows in total. You know that these crows are black because you saw them. But logically, can we really conclude that all crows are all black? Of course not. So, for a generalization to be effective and valid, you would need to observe every single crow in existence. This may be in the past, present, and future. And as we all know, that is impossible, simply because there are too many crows in too many places across time. This brings up to Karl Popper's idea of falsification. He argued that instead of trying to verify a generalization, we should try to falsify it. In other words, rather than proving all crows are black, we should instead look for a one crow that is not black. Finding a single non-black crow would then falsify the claim. But here's the catch. Even falsifying the claim is tricky. We would still have to search around the world for that one non-black crow, and we do not even know the totality of these crows globally. Both verifying and falsifying the claim all crows are black are difficult. In both cases, whether you're proving or disapproving the statement, you're faced with an enormous task. Now let's talk about what makes the claim provable. Theoretically, this statement can be proven, but only in principle. If you had unlimited resources, you could commission a global investigation covering all possible places where crows might be. But in reality, we know that this is not practical. For the next example, imagine you've owned several smartphone models, like iPhones, Samsungs, and a few others. And in each case, you've noticed all of them seem to drain their batteries quickly, usually lasting less than a full day with regular use. So from this you conclude all smartphones have poor battery life. This is a generalization based on your experience with a few models. While it may be true for the phones you've used, newer models with enhanced battery technology could easily prove this wrong. To verify the claim, you would need to test every smartphone in the market, which is impossible. However, finding just one model with long battery life would falsify your generalization, showing that drawing conclusions from limited examples can be misleading and an example of fallacy of hasty generalization, which will be further discussed in the following slides. In most cases, universal claims, whether affirmative like all crows are black or negative like no crows are white, often do not have enough evidence to fully verify their truth. It is very important to be cautious nowadays when making such claims. For example, instead of saying all when the evidence only supports most, or saying most when the evidence only supports many or several, we should choose our words carefully. So when generalizing but uncertain with the evidence, you can use a vague term like many. For example, all the crows I've seen are black. Therefore, many crows are black. This way you draw a safe conclusion.
However, as explained earlier, when using the term most, you are expected to provide evidence that more than 50% of all crows are black, which can be hard to do since the total number of crows is unknown. This is why it is important to align your claim with the strength of your evidence. According to Acuna, there are two requirements that must be satisfied for it to be considered as a good generalization. Number one, the observed cases or sample must be representative of the whole class or population. Number two, and no conflicting case has been observed. The first requirement is difficult to satisfy because it is circular. You will never know whether your sample truly represents the entire population unless you've seen the whole population. Going back to the crow example, how can you know if the 50 crows you've observed are representative of all crows unless you've observed every single crow? One way to get around this problem is by randomizing the selection of your sample. If you shake a box of marbles before drawing one, it ensures that each marble has an equal chance of being selected. However, this is difficult to attain. In fact, at best, we can only approximate it. The second requirement, on the other hand, is much easier to understand. It simply says that if you observe even one exception to your generalization, this claim is immediately disproven. For example, going back, if you claim all crows are black and then someone finds a single non-black crow, your claim is falsified. This is the power of counterexamples in logic. A single exception can destroy a universal claim. According to Acuna, many generalizations encountered are often based on too few cases, which leads to a logical mistake known as fallacy of hasty generalization. Imagine a teacher who asks a student if they are prepared for class and finds that the student is unprepared. If the teacher then concludes that the entire class is unprepared based on this just one instance, they are committing the fallacy of hasty generalization. The teacher is projecting the characteristic of one student onto the whole class without sufficient evidence, which exhibits both bias and prejudice. Another example, imagine a couple looking for a new restaurant to try. They check online reviews and find that 2 customers left a negative review about that particular restaurant, stating that the food was cold and the service was slow. Based on these 2 reviews, the couple concluded this restaurant always serves cold food and has a slow service. Fallacy of hasty generalization was committed here since the couple conducted based on insufficient evidence, 2 reviews, and it could discourage others from trying the restaurant without a fuller understanding of its overall quality. There are 3 guidelines to test a generalization for reliability. Number 1, are there enough cases to support a many claim, a most claim, an almost all claim, or an all claim? It is important to have sufficient examples to justify your conclusion. There is no strict rule on how many cases are needed, but generally, the more examples you have, the more reliable your generalization will be. Number 2, have the observed cases been found in every possible variety of times, places, and circumstances? The more diverse the situation in which you've observed the cases, the more confidence you can have in your generalization. If your sample includes a wide range of time, place, or circumstance, it is likely to be more representative of the whole population. For the third one, has a thorough search been made for conflicting cases? Searching thoroughly for any counterexamples strengthens your generalization. If you find that your claim holds up against possible exceptions, it becomes more credible. So, by following these guidelines for making reliable generalizations, we can avoid jumping to conclusions based on insufficient evidence and strengthen our reasoning skills.
And that is the end of our discussion. I hope that by now you fully understand the Module 3 and 4 of Unit 2. Thank you for watching.